Welcome back. We are still in Chapter 15, Chemical Equilibrium. And our next problem is, when the following reactions come to equilibrium, does the resulting mixture contain mostly reactants or mostly products? So we're really asking, does the reaction lie to the left or to the right? Does it lie toward the product side or to the reactant side? So we have our first reaction here. N2 plus O2 gives us 2NO. And we're given a Kc. So remember that the K constant is equal to the concentrations of our products divided by the concentrations of the reactants. Okay, so I know the words are a little bit sloppy, but just try to listen as best you can. So in this case, and we know that we're going to have some exponents here, and that is determined based off the coefficients. So for this problem, we have our Kc value equal to the concentration of products. So we have NO, and again we have a coefficient of 2, so we square it, divided by our 2 reactants. Okay, and so when we build this fraction, we have to ask ourselves, what is the Kc? Is the Kc very large, or is the Kc very small? So looking at this quantity here, we note that it is 10 to the negative 10th. So anything to the negative power is going to be extremely small, and 10 to the negative 10th is very, 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 very small. Thus, this fraction is going to be very, very small. So in order to get a small reaction, so what about the fraction needs to be large or small? So we're going to do one example of working to the extremes. So if we need to get a small number, should we have a large numerator or a small numerator? So should we have a large number on top or a small number on top? So the answer is we're going to need a small number on top divided by a large numbers on the bottom. So that's telling us that we're going to have a small number of product and large numbers of reactants. So for this first one, the resulting mixture will lie mostly to the reactant side. We will have mostly reactants. So it'll lie to the left. Because this fraction is very small, so we have great denominator, small numerator. Okay, next example. Kc is very large. I kind of gave away the answer just now, but let's go through it and prove this to ourselves. We know the Kc for this reaction needs to equal the products to the power divided by our reactants. So it's very large. So in order to get a large fraction, we're going to need a very large numerator and a very small denominator. Thus, we will have more product and small amounts of reactants. Okay? So the reaction will consist of mostly product. Because again, our fraction needs to be very large, our Kc is very large. So therefore, in our fraction, we note that the numerator must be large, the denominator must be small, therefore the reaction will lie to the right. Okay. So looking at these problems, this is how to tell the direction. It's basically whether we have a large Kc or a small Kc. The larger the Kc, the farther to the left or right. The larger the Kc, the farther to the right. The smaller the Kc, the farther to the left. So how far to the right, how far to the left is determined, of course, by the magnitude of the equilibrium constant. Now you'll notice that these reactions are both gaseous. Remember that solids and liquids do not enter into the Kc expression. Solids and pure liquids do not enter into Kc, only aqueous entities and gaseous species. Okay, thanks. See you in the next video.